What up, Misfits? Welcome to the Misfit Heroes podcast. My name is Chris, and together we are going on a journey. Now, Misfits, I am blessed to be an able bodied 38-year-old man in America. There are others around the world that are much less fortunate and have been dealt physical disabilities while lacking the health care and availability that's granted to us right here in America. Here's some facts that you may not know. Did you know that there are 2.1 million people living with limb loss in the United States, and that number is expected to double by 2050? 185,000 people have an amputation each year. This means that nearly 500 amputations are performed every single day. Around 30% of those people with limb loss experience depression and anxiety. Now, those figures are American numbers, but here is something that we don't hear as often in America. Internationally, the reason for many of those needing prosthetic and orthopedic devices is much more bleak. Landmines account for 26,000 amputees annually, and in many countries, adults and children with disabilities are often targeted for violence and brutalities, leading to amputations and being forced into poverty. The average cost for a prosthetic limb in America can range from $7,500 to upwards of $50,000. Now imagine that number without private health care. My guest tonight is helping to change that figure, and he offers free 3D printed prosthetic devices to anyone who needs one around the world. Jeremy Simon is one of the co founders of E-Nable 3D, an online community that networks patients needing prosthetics with the global 3D printing community. His help in this work has led to an open source, community based approach to global healthcare that has inspired demonstrable change in the medical profession around the globe. We discuss how the project has evolved over the years from a small online community to a group of over 14,000 supporters, how surprisingly easy it is to get into 3D printing, and how 3D printing technology is changing the healthcare landscape the world over. Misfits, please welcome Jeremy Simon.
Playing the Misfit Heroes podcast.
Jeremy, welcome to the Misfit Heroes podcast. I'm really excited to talk to you. You've got some really cool ideas, and I just there's a lot of people that listen to my podcast that may not know a lot about 3D printing at all. And I've recently got into the field myself, and I think it's just this wave of the future. It seems like science fiction that we can just create things from this from nothing. But let's talk about you a little bit. When did you get into 3D printing? How did you get into the field?
Well, I've always been kind of a techie myself, and I love all things technology, whether it be, computers or, VR, the internet, just everything technology has always been of interest to me. And so my last company before this one that I owned was a consulting company, and we did information security consulting, nothing at all related to this. But it got to be, rather stressful, and it came to the point where I decided, this isn't really fulfilling enough for me anymore, and it's taking too much time away from my family. I sold my shares, and I gave myself some time off. I really had no idea what I was going to do next. And in that time off, that was right when 3D printing at the desktop level was really kind of starting to become very affordable and very accessible. This has been around since, I don't know, 1980 something, but it really got big back around, 2010 to 2012. And that's right around the time that I'm talking about. So I decided that I was going to play with one of these things. So I got a 3D printer and started printing some stuff. And like everyone else, I was kind of printing little trinkets, things like that you can download online from sites like Thingiverse, and that's fun. And I was amazed at what it could do. But then I came across this design for a prosthetic device, which led me into the whole E-Nable volunteer community that we'll talk about. But that was what really got me excited about the 3D printing when I saw, wow, you can print real usable items with these things, not just things that sit on a shelf. And that really got me thinking, and it really started to get me excited about 3D printing, which ultimately led me to decide to start my next business, 3D Universe, which has been going for about 8 years now. And we try to help sort of expose people to this very exciting technology of people of all ages. We deal a lot with educators and schools and maker spaces and libraries because we really want to get this into the hands of the next generation. We love to see what they're going to do with it, because this is all going to be part of the workspace, the workplace when they grow up, right? So we basically built this business around that idea of just getting people excited about this very empowering technology, 3D printing and laser cutting and all this other stuff that goes with it. And it's just been so thrilling to see people that have been able to, make their dreams come true. Starting a business by 3D printing things and starting up an Etsy shop and being able to get out of a job that they hated. I just love those stories. And so that's really what got us going with this.
It's really an amazing field, there's also like an online community just in the 3D printing space that is just, I mean, everybody is so super helpful and willing to help you learn and get into it. I mean, it
Right.
sounds like witchcraft, quite honestly, but it's actually not as hard to get into as you would think. And I mean,
No, it's very accessible. Yeah.
yeah, there's sites like Tinkercad and things like that. I've been, which seems to be designed towards children, but I learned I've learned how to model myself off of it. It's really
You
quite
can do
amazing.
amazing things with Tinkercad. I know people who have designed entire E-Nable prosthetic devices in Tinkercad. So you can do quite a lot with it. And it's very easy to learn and, of course, totally free. So it
Yeah.
does make it easy for people to get started with this.
What made you want to start printing prosthetics? I mean, what sort of led you in that direction?
Yeah, yeah. Well, so that was never really on my radar, but like I said, I was just exploring the designs that were available online because back then when I was just getting into 3D printing, I didn't really have a lot of CAD skills. I didn't know how to do a lot of 3D modeling myself to create my own models. So I was just kind of looking at what's available online and I was more focused on the 3D printing side of it of, what can I make this machine do? And so as I was exploring those designs on Thingiverse, one of the bigger sites out there for free to download designs, I came across one of these E-Nable prosthetic designs. At the time, it was called the Cyborg Beast, which was one of their earlier prosthetic designs. And like I said earlier, this just got me really excited. I downloaded the files. I made one of these. I put it together. I got all the different assembly materials I needed, put it together, found that it actually worked as expected. And I joined the community online at that part. It had just gotten going. This E-Nable volunteer community was just getting started. And so I quickly got involved. This was back in early 2014. So I certainly didn't start this. There were people before me. Most notably, Jen Owen was the one who really started kind of sharing these stories online. Of it was her husband at the time who had created the original open source printable prosthetic design, shared it as open source instead of patenting it, and that allowed other people to start building off of that work. So Jen started blogging about this work and about this device that they were making for a family in Africa, and really got a lot of people's attention, and people really responded, as you would expect. It's a very heartwarming tale. People just helping another family halfway across the world, asking nothing in return. And
Right.
then not only helping them, but then releasing these designs free, open source. Anybody can download and print these. Just really an amazing and inspiring thing. And Jen Owen really helped to kind of get this started by sharing these stories online. And then shortly thereafter, they posted a video on YouTube showing their work and kind of showing this initial device that they had made with the help of some 3D printers that had been donated by MakerBot. And this YouTube video got a lot of attention. And you know how YouTube videos can be. You almost never see a YouTube video that has all positive comments, right?
Right.
This video had like nothing but positive comments. Everyone was really inspired. They thought it was great. A lot of people were saying, "Hey, I've got a 3D printer. Could I do this kind of thing?" So in comes a professor from Rochester University, John Schull, and he saw this YouTube video and he decided to take action. He set up a Google map and made it public and put a post on this YouTube as a comment saying, "Hey, I created this Google map. If you've got a 3D printer and you want to make one of these devices for somebody, put your pin on this map and let people know that you're available to do this." And a lot of people jumped in and started putting themselves on that map. So John took the next step and he set up a Google Plus community where people could kind of collaborate and talk to each other online and ask for devices or connect with people that need these devices. And that was about the time that I got involved, right as that Google Plus community was getting started. So I found a person in my local community here, an adult. Now, at the time, we were making these devices more for children, and we'll talk about why that is as we get into kind of the people that need these devices and who has difficulty getting access. But I hooked up with an adult male in my community who was born with a limb difference, lived all his life this way, and he actually, so he was. It's something called amniotic band syndrome. It's a pretty common version of the limb difference where you're born basically without the fingers and thumbs. So you have a palm and you've got a functional wrist, but you're just missing all the fingers. That's one of the common types of limb difference that we run into. And that's what this gentleman had. And he had lived his whole life this way. And he had received one of these very high-end professional prosthetic devices, the electronic ones that are powered and actually sense your muscles and can sort of grip when you tighten your muscles. It's called a myoelectric prosthesis. And he had received one of these. He said that at the time he received it, it cost his insurance company something like $42,000. Now, they don't necessarily cost that much anymore, but they still cost thousands for the professional ones.
Right.
Well, I made him one of these because he saw one of my videos that I'd done and reached out and asked if I could make one, and I did. Now, I should explain, these are body powered devices. These are simple, for people that might be watching the video version. Here's an example. This is a simple body powered device where by simply bending at the wrist, you're causing the fingers to operate. So there's no expensive motors or circuit boards or anything like that. They're actually very basic, just ingenious in their mechanics. And so I made one of these for him. And to my surprise, he came back after using it for a while and he said that he loved it and that he was using it far more than his expensive professional device because he found that it was more effective. Among other things, he found that the very expensive one had a lot of false positives. So it accidentally think that he was triggering when he wasn't. So if he was trying to drive his car, all of a sudden it's gripping or opening the grip when he doesn't want it to, and this can be an inconvenience. So he preferred our design, and he did a video with me to talk about that. And that video, to my surprise, kind of went viral. It had quite a lot of views, and Fox News then picked it up and interviewed me on air about it. And so that kind of got a lot of people's attention. And so that led to a lot of people joining the E-Nable community. And so that was kind of the third key event. So we're kind of seen as the three kind of co-founders of the community, Jen Owen, John Scholl, and myself. I've obviously stayed very much involved ever since then and do a lot of things behind the scenes in terms of helping support the community as much as we can. But we all consider ourselves sort of gardeners more than anything else, because this whole thing has just happened by itself. All these people just spontaneously coming together to say, yeah, I want to help. I've got a printer and this is great. Let me help somebody. And everybody is doing this out of pocket. They're buying their own 3D printers, or they already have them. They're paying for the materials. They're paying for the filaments. They're paying for the shipping if they need to send it to somebody. So the people that these devices are being made for, it's being done totally free of charge. Nobody pays a penny for these, and it's life changing. It's literally changing people's lives that could not get access to these types of devices.
Yeah, it's really an amazing project, and the fact that it's all sort of sprouting itself, it's
That's
it's
right.
it's creating itself as it goes. It's really quite amazing. In regards to 3D printing on the consumer level, it is still somewhat of a newly commercialized field, a newly consumer grade field. But I've noticed that recently the barrier for entry into 3D printing has decreased significantly. And there's been a lot of, teaching like STEM in schools. It's a big focus and everything like that.
Absolutely.
For those that are unaware of the ins and outs of the 3D printing and itself, are people able to get involved with your project without, expensive equipment or, modeling
Absolutely.
experience?
Absolutely. First of all, 3D printing has progressed and matured a lot over the last decade, and I'd say that it's been about this decade or so that it's really become mainstream and accessible, like you said. And most schools now, I'd say, at least in the U.S., not in all regions, but at least in the U.S., most schools, anywhere from the K through 12 all the way up through higher education, have some level of access to 3D printers at this point, which is really great to see. Now, it's important to note there's a lot of different kinds of 3D printers. The type that we're talking about today mostly is what's called FDM, and that stands for Fused Deposition Modeling. And that means these are the type of printers that you feed a spool of plastic filament, or think of like thick plastic thread almost on a spool, and you feed this into a hot end, which is like a nozzle that gets very hot, and it extrudes this melted plastic layer by layer. Those are the types of 3D printers that we're talking about here, and those have become very affordable. So to your question, if somebody wants to get involved with this community and wants to be able to actually make these devices, you can get a very decent 3D printer these days for a few $100s. So you don't have to spend a whole lot of money. And a lot of people have done things like set up little, local fundraisers, a GoFundMe or a Facebook fundraiser, will give you all the funds that you need to get that 3D printer going from people in your friends and family circle or your local community. So a lot of people have done that in order to help get that first 3D printer going, but it does not take much. And most of those basic 3D printers have everything you need to do these things that we're talking about, this project here. You need something that's of a reasonable size, so you want to steer clear of the really teeny sort of mini style 3D printers that are out there. And you want something with a heated bed, which is a very common feature in most of these 3D printers. That means that you can use a wide variety of different materials that would need that heated bed so that it can stick properly. And that's about all you need. Any basic 3D printer with a heated bed and a decent size build area can be used to make these types of devices. And like I said, they're not very expensive anymore, and they're not hard to learn.
Yeah. Now, who creates the models for these prints? Because that's sort of another side that people don't necessarily jump right into.
Yeah, like I said, that was me when I got started. I had very little CAD experience, and I've learned quite a
I'm
lot
not
over the
sure I
years. But
understand.
I was quite a beginner when I got started with 3D printing, and so there are a lot of people like that in our community. You do not have to have any CAD skills or any 3D modeling skills to get involved, and the reason is all of these people in our community that have created these designers are just volunteers. They're people like you and me that do have CAD skills, some of them quite amazing CAD skills. They've developed these designs, and just like the original one that was shared 10 years ago when we started this community, all of these designs are being shared as open source. So it started with that first one. It was created by a gentleman named Ivan Owen. He was the one that did the modeling originally. He shared that under a Creative Commons share alike license, which means anybody can use it, they can modify it, they just have to be sure to share any derivative works. And that is, in fact, inspired people to do just that. So you can kind of look at we have kind of a family tree of all these designs that have sort of evolved out of those original works, and it's just amazing. All of them have spawned from that first project. People just finding ways of making it better and improving upon that original design. And all of these designs have been shared as open source. So anybody can download them. If somebody has an idea of how to make one of them better, they can do that. I'm working with a group right now to do exactly that, kind of taking all of the designs that have come together so far, and we're kind of taking all the best features of them and bringing them together into an even better design. So yeah, the designers are all different people all over the world. Right now, one of our most popular designs is called the Phoenix Hand, and this was designed originally. It was a number of different volunteers in the U.S. And I don't recall the individual names, but then a group in the UK picked up the banner called Team Unlimited, and they came up with sort of the next version of the Phoenix Hand, which became very popular. So all sorts of different people have gotten involved. We've got a gentleman in Australia who developed the one that I showed on screen here a moment ago called the Kinetic Hand. I was part of a team that came up with an earlier design called the Raptor Hand. So we've got all these different people. Anybody can be a designer, and they're just sharing them with the whole community as open source designs. And so we've come up with this sort of catalog of all these designs, each one created by different people, and all of them shared freely with the world.
For the end user, the people that are actually getting the devices, um, you know, how do they get involved? How do they request a prosthetic? And you said that they're free. I mean, how can they, hook up with the people creating these?
Absolutely. Well, our hope is and always has been that the people that receive our devices are not just receiving them like you'd order something on Amazon and have it shipped to you. That happens. We have people that just make a device for somebody and treat it almost like a transaction. But ideally, we want these people to be involved, like you said, as part of our community. They're in the best position to help us make these designs better. And so we've started calling them device pilots recently, because that's kind of how we think of them. These are people that help us very much like a test pilot would help test out an experimental aircraft and give feedback on what works and what doesn't and how to make it better. That's exactly what these folks do. And we love it when folks get involved like that. So one way of getting involved is like that, where you're actually taking part in the feedback cycle and helping us to make these designs better. But at the very basic level, if you're just somebody that has a limb difference or knows somebody with a limb difference and you just would like to get access to one of these devices, you can just go online to our website. And I guess the main site I would point people to start with is enablingthefuture.org. That's just the main site where Jen Owen has been telling all the stories of our community. And from there, you'll have links over to where you can request a device and how you can get involved as a volunteer if you want to, or how you can support our community. So if you just go to enablingthefuture.org and click on there's a little icon on the front page there that says need a hand. Just click there and it'll take you right where you need to go to request one. And we provide several options. If some people that maybe are more technically minded and want to actually be part of making their own device, maybe they have a 3D printer of their own, or if not, you can get access to 3D printers without buying your own. A lot of local libraries now are making them available to their local communities free of charge. A lot of schools would allow people in their community to come and make use of them. So people can kind of check in their local communities. Maker spaces are also popping up, public maker spaces. So there's a very good chance that in your community, you can find a 3D printer that you can just bring these files to and say, here, I'd like to print these, and they'll print them for you. So if somebody wants to do that, we can work with people to help them make their own device. But if they're not up for that, we'll pair them with a volunteer that will do all of that for them. And we have a whole process that we go through where we take measurements and we get the right sizing details, and then we scale the hand and do customizations if needed. And then we 3D print the parts, and there's an assembly process and some testing that we do. And then we go through the fitting process with the end user and all the follow-up and everything that goes on after that. So it's not just a matter of 3D printing. There's more to it than that. But yes, we've made it quite easy, I think, for people to get a device and even get involved beyond that if they'd like to.
Well, I love the initiative that's being taken with this, and I also like the fact that you just said that you're trying to sort of create this community around it and create
That's right.
relationships between people. I like that aspect of it, because I could definitely see, well, yeah, I just print this out and I just pop it in a box and put it in, and there you go. Now I'm
That's right.
Amazon for prosthetic hands. I get that.
Right.
I was doing a little research before we got on, and I was looking at the professionally created prosthetic devices, and from what I saw, the average cost for them was anywhere from like $7,500 to like $15,000, and that's a hefty investment. I've got right here. I recently printed out the this is the Phoenix Hand V3 that we were talking about,
Yep.
and this took $4 in filament
Right.
to print
Right.
out. I mean, what do you think is the reason for such a cost difference? Is it just the research and development that these companies are putting in, or is there an issue with the way that these prosthetic companies are sort of pricing their devices on a professional level?
Well, it's a very complex topic, actually. So we probably won't be able to cover all the dimensions of this. But first of all, I'll point out that let's be clear that we're not necessarily comparing apples to apples when you compare one of these E-Nable designs to something in the price category that you mentioned, because usually the devices in that price category are powered devices. They might be bionic designs that have the muscle sensors and other more expensive components. Even if they're not the powered category, when you get into those professional level prosthetic devices, even if it's a body powered device like ours, the way they're made is entirely different. I mean, there is a different level of quality, and you're talking about, things that are made out of true carbon fiber, the layered carbon fiber for really enhanced strength, and custom molded sockets for the end user. Just it's a whole level class of device. So to be clear, we are talking about a simpler, more basic level of device here. But even those more basic level, when you find those in the professional community, something that does sort of correspond, there's no doubt there's a big difference in price. And some of it is, like you said, there's certainly a lot of R&D costs that are going into that. These companies do have to, cover that somehow. There's also, a lot of other factors, and I don't know all of them myself, but running a business, anytime you're doing this as a commercial enterprise, I imagine there's got to be a lot of overhead from things like insurance and liability coverage and licensing and just all the things that go along with providing medical devices. Again, as I said, I haven't gone too far into that myself, but I have to imagine that adds to the overhead. But that's what's exciting about what we're doing, because I do think that we are, in a good way, putting pressure on those commercial organizations to bring their prices down and make their devices more accessible, because we're providing some compelling alternatives. You'd be surprised how many people we have that come back and tell us that their very expensive professional device is sitting in a drawer and they're using ours. The most common reason that we hear for that is weight. Sometimes those very high-end, high-quality devices are just too heavy to be worn comfortably throughout the day. And so they put one of our devices on, and it's nice and lightweight, and it gives them the basic functionality they need, and they love it. So it depends on the person and what they're looking to get out of it. So there's no doubt there's a huge pricing discrepancy, but we are seeing that change over time. We're seeing more and more of the professional medical organizations starting to be more open-minded to how 3D printing can be incorporated. We have some of these individuals and organizations that have actually partnered and worked closely with E-Nable, and we love it when that happens. The best case scenario in our mind is when our recipients, the people that are receiving our devices, are working with a medical professional, and we're just the ones helping to make the device and kind of get things scaled and assembled, and then the professional handles the fitting and the follow-up to make sure everything is being done just right, because we're all amateurs. We don't know what we're doing. I mean, I think we've done a pretty good job for the people that don't have any other options, but we always tell our people that if you have the option of working with a medical professional, definitely do that, because you'll have a better outcome that way. And there are quite a few of those medical professionals that have been enthusiastic supporters of what we're doing. Others have been a little bit more hesitant to work with amateurs. So it just kind of depends. And we're trying to form more of those partnerships with those that are willing to embrace this for those people that can benefit from it.
Yeah, I was going to ask, in dealing with these medical professionals, are you sort of altering the market a little bit? I mean, is it an increasing request from them? Are they more open to that now than they were previously?
Well, again, it varies a lot, so I don't want to overgeneralize. But based on my own experience and those medical professionals that I've worked with, I've heard a couple of things most commonly. One thing that I hear of is just access. Some of their patients simply don't have insurance, simply don't have the resources to get one of these professional devices, and so they love the idea of having a free alternative that they can connect these people with if they simply can't afford or get access to these more professional devices. The other thing that I hear very commonly is even when somebody has access, has the insurance coverage, and they're going to be able to get fitted with a professional prosthetic device, that process of going through the approval and doing all the insurance documentation and then working with the professionals and the fitting and everything, it can be a year or more before you get that device. And so I've also heard that they love the idea of using our E-Nable devices as a short-term solution, because we can turn one of these around in a week or two. And somebody could have a basic device that they could use for that year while they're waiting to get something maybe higher end.
Well, I love the whole community aspect of it. You know,
Yeah.
I think that in the future, I just feel like there's more of a need. You're kind of creating this community based healthcare aspect of it. Obviously, you're not going to take anything away from doctors and medical professionals and things like that, but I love the idea that it's being opened up to sort of this open source. Open to the community creation of these tools and things like that. Do you see any other areas aside from healthcare where this is sort of happening with the 3D printing community?
I do actually. Specific to the 3D printing community, I mean, Enable was always intended to be about assistive technology. Now, it just happens that we've been very focused on prosthetic hands and arms. That's kind of been our main area of focus and action. But the idea was always broader than that. And we do have a lot of volunteers that are doing work beyond prosthetics. So assistive technologies can include things like devices that you could 3D print for people that might have sight impairment. They might be blind, and you can 3D print, for example, three-dimensional objects like, maybe cartographical data, so that they can understand, the geography or contours of terrain, or models that would help to illustrate concepts like mathematical concepts, or even 3D printed braille and things like that. There's all kinds of things you can do for them. There's all kinds of other assistive technologies you can do for other kinds of conditions, things for the hearing impaired, or things for people with various types of physical challenges. And in fact, IKEA set up a whole site for, it's called Visibles. It's really wonderful. It's kind of oriented around IKEA furniture, but it's all of these free downloadable 3D printable files, so that you can make like add-ons that make those things more accessible to people. So handles that make it easier for people to operate a sink or open a door if they have a physical disability, and things like that. And it's just wonderful to see this. So there's people coming up with things like this for all different areas. but it's following this. What gets me excited is it's all following the same idea of open source designs, free for anybody to download, print for yourself, share. Nobody's trying to make money off of this. It's really inspiring.
I was looking at something else the other day. I'm not sure if there was a hacker group, or they call themselves a hacker group, but they created this alternative to the EpiPen. And their idea
Mhm.
was that diabetics are being charged, I want to say somewhere in the neighborhood of like $600 to $700 on average for an EpiPen. And they created this device that's, I want to say like $30 and an alternative to that.
Yeah.
And, you know, again, it's not a professional piece of equipment, but the CEO of the company that creates the EpiPen actually was testifying before Congress because of the pricing structure of this, and her idea, and it's entirely correct, but her statement was that, hey, I own the company, I can charge whatever I want to for that. Do you think that there is an ethics issue in America with these sort of with these pricing strategies when there are alternatives that can be created? Or do you think that, in the future, um, are these types of devices, do you think they will be able to affect those markets, differently, to create more competition?
Without a doubt. I mean, these technologies are only getting better. They're getting more affordable. Their capabilities get better. And so, yes, people are going to be able to do more and more where they used to have to rely on big companies in order to do these things. And that will put pressure on organizations to change their approach, to change their pricing strategies in some case. So, no, I cannot fault that woman for the statements that you shared. That yes, sure, she owns the company, she can charge whatever she wants, but I think it's the responsibility of the general public to put pressure on people like that to show that that type of approach is no longer viable. Sure, you can be greedy like that if you want. That's your right, but your company's going to fail if you insist on holding to that ground. And so I think people are going to have to adjust their thinking, and it's people like this, just ordinary individuals. I don't know this hacker community that you mentioned, but ordinary folks that just take action to say, look, we can do this and it only cost us this much. And that sharing that and getting the word out about that puts a lot of pressure on these companies to you know answer for that, and eventually I think start making some changes. So I do hope to see that. I think that's one of the things that's exciting to me. This all of this digital fabrication technology, I said it earlier, it's very empowering, and that's why it's so empowering, because it allows people to do things that I never could have made a functioning prosthetic device for myself in my home. Certainly not with my skills,
Right.
years ago before I had a 3D printer. I guess it was possible if you really have some good, handiworking skills, but it made it so much more accessible to make things like this. Nowadays, if I want to, if my, things like this have happened, a little part on a washing machine breaks or a part of a vacuum cleaner breaks, I no longer have to go to that company and pay them $50 for a replacement part. I can take the broken part and I can model it in CAD in about 30 minutes. I can 3D print one in about 2 hours for a cost of about $1.50, and I'm back in action. So it's going to change things, and I think companies are going to have to respond to that over time as more and more people start to get hip to this.
Yeah, I think that, a lot of this, I definitely don't think that we've even reached the tip of the iceberg with the whole 3D printing community as a whole. I don't think. I think it's very, I still, it's, I've seen a lot more adoption recently, but I still think it's very new in the technology space as a whole. One of the things that I wanted to talk to you about is a lot of the reasons that I see that the enabling the future and the enable community has been created is it appears to be kind of an issue with, it's a deeper issue than just 3D printing, and it's a deeper issue than just creating these new things. There's kind of a little bit of an aspect of wealth inequality, or as far as the reason that you even need this enable community. And I think that issue could drive what I see, at least, of the need for these devices, but also the creation for these devices. How do you feel about actually having the need for this program?
Well, it's how do I say this? I mean, it's I feel great about what we're doing, and I feel great about the model that we are putting forth that can be applied in so many other areas. I don't feel so great, to your point, about the fact that it's needed and why it's needed. Um, so let's talk about that a little bit. I mean, there's a couple of major reasons that we have helped so many people, and hopefully we'll be able to continue helping so many more. One of those reasons, and really where we got started, was mostly in the United States and mostly with children. That's the main reason for that. It comes back to insurance coverage. Obviously, the United States is a fairly affluent population for the most part, and so we're better off than a lot of areas. And so most of the people have some kind of access to insurance, but even so, insurance doesn't want to cover a prosthetic device for a child because they're going to outgrow it in a year, and then they're going to have to go and spend all that money again. And so it's very hard for children to get any kind of access to prosthetic devices, even if they have insurance. And so that was what created that initial need. And so that was why the devices that E-Nable was making in the beginning, and you might have seen a lot of the photos and videos earlier on, most of them were very fun, kind of bright colored devices, a lot of kind of superhero themed hands and arms and things like that. And the kids in the US loved that. And it helped get a lot of publicity, and that's great. But we quickly started to realize that the need was much, much broader than that. And unfortunately, it's kind of hard to learn some of what we went on to learn, which is that a lot of these regions, not only are they not nearly so off financially, a lot of these places just don't have anywhere near the kind of financial means that it would take to get these devices, but they also they don't have the physical means. They don't have physical access to the medical professionals or the kinds of clinics or facilities that would be able to get them a device, even if they could afford it. They would physically have to drive, across the country or get across the country, and it's just not an option for so many people in so many parts of the world. To make matters worse, in many parts of the world, we started to learn that it's not just a matter of congenitive limb difference, things that people are born with. It was horrifying for me to learn how many places in the world there are kids having their limbs chopped off just so they can be put out in the streets to beg for money, out of that sympathy. I mean, just horrible, horrible things that are going on. And so some parts of the country have thousands and thousands of people that need prosthetic devices. And what we're also learning is that in a lot of those regions, there are huge cultural differences. In the US, kids love these fun colored designs, they love the superhero things. In a lot of these other regions, there's a cultural stigma associated with these limb differences, and people don't want to stand out. They want these prosthetic devices to blend in as much as possible. And so we've learned to start making these prosthetic designs using skin tone colors so that we match their skin tones as well as we can. And so we're able to kind of help serve a different need in that way in those specific regions. So we're learning a lot about the fact that there are many different reasons in different parts of the world of why people can't get access to these types of devices. And we're doing our best to address all of those. We now have 200 chapters registered in, last I checked, I think 53 countries around the world, and tens of thousands of volunteers. So it's been amazing to see how the community has grown to address all of those different areas of need throughout the globe.
It's crazy how many posts I saw on there that were from international users that, um, you know, it's all over the place.
It
Um,
is.
what does the project need most moving forward? Do you need more end users? Do you need more volunteers? Do you need more funding? I mean, what is your main need right now?
I would say right now, the main need is actually getting the word out there, and not getting the word out to get more volunteers, because we've actually done great with that. We have lots of volunteers, more always welcome, of course, but we're not hurting for volunteers. What we need more of is the people actually requesting devices. Believe it or not, we actually have a surplus of volunteers and a shortage of people asking for these devices. And so we've gotten very creative in finding all sorts of other ways that our volunteers can help. And I should have mentioned that before when we were talking about what people need to get involved. You don't even need a 3D printer, because there are so many other ways you can help, whether it be with translating our documents in other languages, or doing development work for our online infrastructure, or doing CAD work for some of our custom cases. I mean, there's so many different things people can do. So just if you're interested, check us out. And there's definitely a way to get involved. But we that's big, a part of the reason that we've been diversifying so much on the volunteer side is because these volunteers are not able to find recipients that they can make a device for. So what we need most is to get the word out to people that there is an avenue for you to get a prosthetic device completely free of charge. It might not be the most, high end, most advanced prosthetic, but it's a very functional, as far as a basic body powered prosthetic goes. The way we always like to talk about our devices is that they are substantially better than nothing. Certainly not the best thing you can get, but that really is accurate. It is substantially better than nothing, and unfortunately, that nothing is what a lot of people have. So if you are someone or know someone who is stuck with nothing, who has a limb difference and does not have anything to use, check us out, because we really need that more than anything else right now. We need more people coming to us to get these devices. So it's really a matter of just PR, getting the word out there. Funding is always helpful. Financial support always helps. We've been lucky enough to have some very generous supporters, and those continue to support our work because we've done great things with their donations so far, but we can always use more of that support as well.
Is there any way on the website, is there anywhere for medical professionals to get involved and contact you so you can sort of bridge that gap between the medical community and the 3D printing community?
Absolutely, yeah. The main platform that we use now for collaboration within the E-Nable community is something that we call the E-Nable Hub. And the E-Nable Hub, you'll find the link for that on the main E-Nable website, enablingthefuture.org. And the hub is a platform that's divided into what are called spaces. We have different spaces for all the different kinds of topic areas within the community. And we do have one set up for medical professionals, and so they can join us on the hub there. They can join into that medical professional space, and it's a place that we have set up for all of them to collaborate with us and get involved in projects, and for us to help each other out in moving this forward. So yeah, just join us on the hub, and that's the best way to connect with all of us, and we can kind of talk from there about how to move forward. It's very common for people to reach out through the hub, and then once we kind of see what they're doing and they introduce themselves there, somebody like myself or John or one of the other kind of key players there will connect with them, and we'll often get a Zoom meeting set up and talk more with them about how they can get involved, and we'll kind of go from there. But going to the hub and introducing yourself is a great way to get started.
Moving forward, what do you think the future of the 3D printing in general is? What needs need to be met? Do you think it's more consumer adoption, or do you think it's more deeper education? I know that STEM is sort of taking over in schools and things like that, but I mean, what do you see? What needs do you see arising for the 3D printing community to sort of adopt?
Well, it's just more of what's already happening, right? Like I mentioned earlier, 3D printing is getting better every day. It's getting more and more capable while the prices are coming down more and more. And so, as that happens, more and more people jump in, more and more people decide, okay, it's finally time for me to get one of these things. So, that trend is going to continue. The machines are going to keep getting better, and they're going to keep getting more affordable, and you're going to see them popping up in more and more places. And you're just going to see them becoming more and more a part of our lives. And the more they do become spread around, that means they're going to be more and more accessible. Because even if you don't have one in your home, like I said, chances are you can go down to your library and there's going to be some set up there that you can use. And so the more that we see people learn about these and how easy they are to use and realize that they actually do have access to them, you're going to see people coming up with ideas more and more of how they can be used in new and better ways. Because again, I loved 3D printing when I got into it. I thought it was so cool, but it wasn't until I came across that E-Nable prosthetic that my mind really was blown, because that to me was where I started to realize this machine is not just for printing out little things that sit on a shelf. This machine can make things that literally change somebody's life for the better. That was just totally mind blowing to me. And people are realizing that in new ways every day. People are using 3D printers to come up with solutions for providing clean water in areas that people don't have access to that. You mentioned the EpiPen. There were people 3D printing solutions in the pandemic for helping with mask solutions, or solutions, the adapters for the breathing machines, and just all kinds of amazing solutions that people are coming up with, just new and creative ways that you can use these 3D printers, and that's just going to keep happening more and more.
Well, I love it. I love the field and I love your enthusiasm about it. And I think that, it's really it's really going to grow people's needs and meet just so many needs in the future. I think it's an amazing field, and I think what you're doing in it is great. I love what you've done with the community. So kudos.
Yeah, thanks. It's very exciting.
We're getting down to the end of the episode, and towards the end of every episode, I ask all of my guests one question. And it's one question, two parts. What was the last goal that you completed, and what's the next goal that you want to set for yourself?
Well,
Yeah. And
I,
there's
I,
always
I
a
gotta,
pause right there.
there is, and I know exactly the answer to both. I just got to think about how to explain this without it getting too technical, because the goal that I just completed, I've been working with a very talented team of volunteers in our community. I mentioned this project earlier. We're working on developing a new E-Nable design, taking the best of all the designs that have come before, and we have made phenomenal progress. We're actually getting close to something that we'll be able to release to the community, and it has some great innovations in it. But one of the main things we wanted to do differently with this design is we wanted to make it fully parametric. And what I mean by that, this is where it gets a little bit technical. When we make these 3D printed designs, all of these different parts they need to be scaled, right? These parts are all designed at a sort of a default scale, what we call 100% scale. And you almost always have to scale it up or down so that it fits the end user, right? In most
Right.
cases, in our designs, we're scaling up. And when you scale up all of the parts, everything in the part is getting scaled up with it. So the spaces between the moving parts get scaled up. If you have holes where screws goes, those screw holes get scaled up. The channels where the cables go get bigger. Everything gets scaled together. And that means that when these hands get really big, the joints kind of start to get a little bit wobbly because you get a little bit of play in the joints. They start to make a little bit of noise, things like that. With parametric scaling, when you design when you design things parametrically, what you're doing is you're inputting variables so that when we scale this design, we can scale everything overall, but we can keep certain parts the same, so that the spaces between moving parts don't change. The screw holes stay the same. The channel size stay the same, but everything else scales around it. I won't get into the technical parts of how that's done, but it's quite an achievement to have been able to do it for the entire design throughout all the parts. And the challenge was figuring out, how do we now deploy this fully parametric design in a way that people can put in the measurements, right? So the idea is you go out in the field and you take measurements from the person that needs this design. And we want you to be able to put in those measurements and get back the scaled files without having to go through a whole bunch of technical stuff, right?
Yeah.
And so the big breakthrough that we had recently was coming up with a way of developing a very simple front end web tool, which we're going to turn into a smartphone app, so that people can very easily, it'll walk you through taking these measurements with little pictorial guidance. You just take the measurements and then you pick the design you want, you say, generate my STL files, and then it'll feed everything to the back end using these APIs that we found. It'll generate everything parametrically scaled, and it'll zip up the files and give them to you. Again, I know I'm getting a little bit into the weeds here, but it's a lot. It's a very important development for us, because what it's going to mean is, moving forward, it'll make it much easier for people to get all of the properly scaled files that they need without having to get into all the CAD stuff behind the scenes, which can get pretty technical. And so we're going to be rolling this out in the near future at our community, this new tool along with this new design. And so that's the big goal that I've achieved recently. I'm saying it even though it hasn't been rolled out yet, because it was a major breakthrough to kind of figure it all out. And it did all just come together recently. So we have a prototype, we've got it all working, and we're getting ready to roll it out. So I would say that's the most recent goal, and a very exciting one for me. Um, the next goal is something that I'm working on with John Schull, one of the other co-founders of the E-Nable community that I mentioned earlier. He and I have been having a lot of discussions about the global climate crisis, the ecological situation that we find ourselves in here, which we are both very concerned about. And he and I have been talking a lot about the nature of that challenge and what we're doing to the planet and what we can do to turn things around. And he and I have been having a lot of discussions about how all the governments and the big corporations, they're all focused on, carbon reduction. And they're focused in the wrong place, because carbon reduction is great, but you reduce all the carbon you want, it's still going to take hundreds of years for that to really have the effect that we need in terms of temperature reduction. It's changing our farming practices and changing the way that we're working with the earth in order to bring all of that existing trapped carbon from the atmosphere back into the soil. This is what can change the situation in a matter of years. And we've been talking about how we can take the model of the E-Nable community, people all over the world who have said, we're not going to wait on the governments and the big companies to solve our problems. We're just going to come together and we're going to help each other and we're going to take action. And we want to look at what can we do to take that same model and apply it to this climate situation. And we think that if we get enough people together, tying together the philanthropists who want to invest their money to help save our planet, tying that together with the volunteers who want to actually do the work on the ground, our goal is to buy up land to where we can apply these types of farming practices to regenerate these degraded parts of our globe, and bring back healthy soil that's actually regenerating the climate. And our goal, we're putting together a program with the goal of reducing temperature by doing this to 10% of the global land mass within the next decade, which should reduce temperatures by 1 degree Celsius. We are working to form collaborations with a number of like-minded groups that are already working on this. There are some amazing people already doing work in this area, and John and I are really right now trying to pull together all these brilliant folks to kind of form a new community following on these very same successful models that have come up very organically through this E-Nable community. So that's the next goal that we have, is to apply this model to something that we think is an even bigger challenge for our population.
Well, I've got two things to say about that. One, I do understand what you were talking about earlier with the app and creating that in the future with the sizing. That would
Yeah,
be an amazing feat because it's so needed. I've searched high and low and haven't found a mobile app in particular that works well with any of this, and that would save
right.
so many people so much time.
Exactly.
And two, the other thing is, Misfits, if you want to know why we need to move our children in schools to STEM education, what he just said is life
That's
changing
right.
for so many people. That's amazing. So
It is.
wow, I'm very
And we
impressed.
love that. That's something that we have seen through E-Nable. We now have hundreds and hundreds of schools that have brought E-Nable into their curriculum and have actually worked with their students to take them through. We've got curriculum materials to help them with this. They've done amazing work of bringing E-Nable into the educational arena and orienting it around STEM. And we have heard from so many students that have been inspired to pursue careers in engineering or orthopedic, occupational therapists, and those types of careers because of being exposed to this. And that is just so thrilling to hear, because it's too often education can be just filling kids with information, and it's so wonderful to bring something into their classroom that connects them with something really meaningful, where they can actually be a part of changing somebody's life and see that they can actually learn a skill set that can help people. It can really do something meaningful. Talk about inspiring kids to learn. It's really powerful.
Yeah, Jeremy, I really appreciate what you're doing, and I think that I agree. I think the learning environment. There are so many kids out there that have such a diverse set of interests, and the way that they learn is, I think, so much more important than where they learn or how they're doing it. And it's just exciting for the future to hear what you're talking about. It's really
Yeah.
cool. I want people to go check you out. So I know you said earlier too, before we got on the podcast, you have a podcast of your own as well. I mean, how can people check that out?
Yeah, sure. So we do a podcast called 3D Universe Untethered, and you can find that at 3duniverseuntethered.com. And we basically do interviews very much like yourself. We picked the name Untethered for the same reason, that we like to keep it loose and informal. And so we just sit down and interview people that are working with digital fabrication technologies like 3D printing and learning about the very cool things they're doing with them. And so if you check out that 3duniverseuntethered.com page, you'll see all the past episodes we've done. And there's some great stories in there, just very inspiring stories of what people have done, things that I never would have imagined even were being done, like the one we just had, some people doing amazing work with 3D printed fabrics and just things that I couldn't believe they were creating with these 3D printers. So we hear all sorts of cool stories through that program.
Well, that's awesome. I'm definitely going to go check it out. Misfits, go check Jeremy's stuff out. How can people check out the E-Nable community again? And do you guys have social media or anything like that as well?
Oh yeah, absolutely. You know, if you search for E-Nable with the dash there, we have a dash in our name, so it's E-Nable. And you know, if you search for us on Google, we'll come up. You know, we've been active for a long time, so we're not hard to find. But the main website is enablingthefuture.org. No dash in that one, just enablingthefuture.org. And that site links to all of our other online resources because there are several of them. So I won't give you all those URLs, but they're all linked from that main site, enablingthefuture.org. So start there.
Awesome. Well, Jeremy, thanks again for coming on. This has been super informative, and I know a lot of people are going to get some good information from it. Misfits, go check out Enabling the Future. I think it's a really cool website, and what they're doing is just tremendous. And you would be amazed how easy it is to get into 3D printing as a whole. I think it's really cool what you're doing for the entire community. So thank you again for coming on, and thank you again for doing what you're doing. I really appreciate it.
Thanks for having me, Chris. It's been a pleasure.
All right. Well, Misfits, I'm going to go ahead and wrap this guy up. Thank you again for listening and have a great evening. Well, Misfits, we did it. That's our episode. I want to thank you so much for listening, and thanks again to our sponsors. If you want to support any of our sponsors, there are affiliate links on the sponsors tab of our website at www.misfit-heroes.com. You can also find links to all of our social media there, so follow us for immediate up-to-date info about the podcast. Please, if you enjoyed this podcast and you want to help me out, do me a favor. Hit the subscribe button so you're notified of new episodes as they're released, and make sure to leave a rating or review of the show on Apple Podcasts and YouTube. Truly, Misfits, I love you. Thank you so much for listening. And until the next episode, be kind, love one another, and be a hero.